I'm going to discuss about one of the functionality which is there in the copy to deep copy and shallow copy, which is generally being used. Now, in this case, the behavior is different in a flat list and a nested list. So first of all, we'll be discussing about the flat list. It's a There is no nested mutable objects in a particular flash list, so there's only integer here. Now what happens is like when I'm doing copy to deep copy, this is the functionality with which we call deep copy. So when we are doing copy to deep copy, then that particular list ls. Now what is happening here is like ls underscore deep 0 when I'm changing it to 100, then this particular list will remain unaffected. As you can see here, the original list is not changed because we are specifically changing ls deep copy, ls underscore deep, which is there, and we have already created a deep copy for this. For the shallow copy also, we can do like copy.copy ls, which this is used for a shallow copy. And then when you have like ls underscore shallow 0, and I'm changing this particular object, like this particular element of the first element in the particular list, then I'm changing it to 200. Now as you can see that when I'm printing the original list, it remains unchanged. When I'm doing a deep copy, then you can see that 100 is there, and like 100 is actually getting changed at the 0th index. And for the shallow copy, it's like the 200 is getting changed for the particular uh, index. And shallow and deep copy behave the same here, because now this is a very important point, because this is what I missed in the interview. I thought both of them, like deep copy creates a new object in the memory, and shallow copy does a new object in the, like it does not do the new object, it's referring to the same element. But that's not true here, because in a flat list, so the integers are actually immutable ints. So that means the ID will obviously get changed, but the outer structure would remain, like the elements that we are receiving will remain the same. So they'll not get changed. So the shallow copy is updated, and it is updated, but as shallow copy is actually pointing to this particular list, it doesn't change, it remains the same. But that thing changes when we are having a mutable object, like list is there, and it's a mutable object. Now for 1 and 2, it's first element in the list. This is a nested object. Now here the behavior will change, because when you're doing a deep copy, then we are getting space created in memory, which is a different space. So 0 0 element in the 0th index for the 0th value, so 1 will change to 999. That's what is happening here in the deep copy. But when we are doing a shallow copy here, the object is changing for triple, like the first element is actually changing 888, and it's referring to the nested part. So when it's changing it to 888, the original list is also gets changed. So this is what we have to keep in mind. In the flat list, this behavior was not happening, but in a nested list, it will happen, because the list is a mutable type, and integer is actually immutable. So that's why this doesn't work here, but it works in nested objects. So I hope you might have gained something. This was a thing which I missed in one of my interviews. As on a flat list, it's not important that when I'm changing the particular index, then the value is changing for the original list also. But that is not the case for the flat list, only because the integers are immutable objects. So for immutable object does not get changed, but for mutable objects it will get changed. So I hope you might have gained something from this video. Thank you, and please subscribe for more.